Scholars, it's Miss Sillin. I miss you and I hope that you're all doing well. This week you should be working on week 3 in your distant learning math packet. This packet looks like this on the front. And week 3, if you keep turning in the packet, says week 3 math packet, 2nd grade, March 30th through April 3rd. Okay, so this week we are focusing on lessons 11 through 15. I hope that you all have started lesson 11. I'm going to be reviewing some of the answers and I want you to check your answers in the upcoming slides, okay? If you have not completed it yet, please pause this video and I would like you to work on that first before watching this lesson. Here is this week's distant learning schedule. Yesterday was Monday, March 30th. You should have completed lesson 11. The objective was to use different strategies to make $1 or make change from $1. Today is Tuesday, March 31st, and we are working on lesson 12, solving word problems involving different ways to make change from $1. Tomorrow, on Wednesday, you should work on lesson 13. You can read the objective there, solving two-step word problems. And then Thursday, April 2nd, lesson 14, we're going to move into something different, measuring objects using an inch tile and relating it to an inch ruler. And Friday, April 3rd, is lesson 15, and we are applying concepts to create our own inch ruler and measuring length using inch rulers. Come back to this slide if you are unsure of which lessons you should be completing on which day. All right, so here is yesterday's sprint test, lesson 11, set A on page 14. And I'm going to provide the answers here for you. Remember to put a check mark next to it if you got it right, and then you just put an X through it if you got it wrong. And then you always write your total correct at the top here. Pause the video here to check over your work. Moving on to set B, page 15. I will provide the answers here, same thing as last time. And then at the top, you have a chance to figure out your improvement. So that's how many more you got correct. So say you got to 16 on set A, and then you got to 21 on set B. We're going to count how many more that is. So 1, 2, 3, 4, 5. You would write plus 5 at the top for your improvement. Pause the video here to check over your answers on set B. Here is lesson 11's application problem. You are solving for 2 questions. So which coins does Tracy have in her purse? And then how much more money will Tracy need if she wants to buy a bouncy ball for $1? Okay, so the 4 coins that she has are 3 quarters and 1 dime. And then how much more money will Tracy need if she wants to buy a bouncy ball for $1? 85 plus what equals 100. Counting up, Tracy needs 15 cents. She will need 15 more cents. Lesson 11's problem set on page 50. If you have not completed this work yet, please complete it to your best ability first before checking over these answers. All right, starting with number 1, correct answer, 45 plus 55 cents equals 100. B, 15 cents plus 85 cents equals 100 cents. They are using the arrowway strategy here, starting with the part and adding up to get to the whole. The whole is 100 cents. This is the most efficient strategy in this lesson. If you are unable to do the arrowway, you can always go back to using the chip model and just use the subtraction way. So for this problem, I would do 100 minus 45, looking at this problem here, and it would equal 55. So you could use the chip model if needed. And another option is to use your quick tens and ones. All right, C, 57 plus 43 cents equals 100 cents. D, 29 cents plus 71 cents equals 100 cents. I'll do an example to show you what the chip model way could look like. So problem A, I would switch it to 100 minus 45 equals what? Draw my chip model. And draw 100. I can't take 45 away because there's no units in my tens and ones place. So I'm going to unbundle 100 and make 10 tens. And I need ones. Unbundle 110 and make 10 ones. Here's what your place value chart should look like. And I'm going to subtract 4 tens and 5 ones, counting what's left, 5 tens and 5 ones. I got the same answer as the arrowway strategy using subtraction on a chip model, 55 cents. Now this way is a little slower, so that's why we're trying to work on using the arrowway as a more efficient strategy to count up from the part to 100 cents. All right, and you can check over problem 2's answers below. The number bond model is not super important. That's just showing the relationship of where the parts are in the whole. I would focus on if you are showing your work and strategy to find the missing parts. So here's the arrowway again, counting up to 100. Page 51, here are your answers. A is 67 cents, B 45 cents, C 72 cents, D 57 cents, E 81 cents. Again, the arrowway is being shown here. On some of them, instead of counting up, they're able to subtract. If you are struggling with the arrowway, please go back to using the chip model way. And your homework page. Remember that in the videos, we are saying that you can send a picture of these homework pages for Grower Team Points. I haven't received any pictures yet. I think I've gotten one from someone. So please, please, please make sure that you are sending us pictures of your homework pages for Grower Team Points. Pause it on this slide here to check over your answers on the homework page. All right, moving on to today's lesson, lesson 12. Your sprint test today is adding across a 10. So this is addition. Make sure you pay attention to that symbol. And I have a timer here for you, so no need to set your own timer. On your mark, get set, go. One minute left. And time's up. Underline your last problem and have somebody check over the answers for you and write your total number correct at the top. Moving on to set B, seeing if you can get more problems this time. Okay, pencil up, on your mark, get set, go. Time's up. Write your number correct at the top and then figure out your improvement. So if you got 15 on the first side and 20 problems done on this side, your improvement would be +5. All right, scholars, it's application problem time. Lesson 12, application problem. Richie has 24 cents. How much more money does he need to make $1? I see 24 cents and then $1. $1, remember, can be changed to cents. So $1 is the same as how many cents? $1 is the same as 100 cents. Richie has 24 cents. How much more money does he need to make 100? Okay. Doing the best you can, draw a picture, a number sentence, and words to explain your thinking. You have 3 minutes to solve this on your own. If you get done early, you can move forward to the next slide to check over your work. You may begin working. All right, you should be finishing up your work if you're not finished yet. Time's up. All right, here is how I solved it. So you could have counted up using the arrow way, or I have another example here. Here is an example of the chip model way. So I changed it to 100 minus 24. I had to unbundle and make more tens and ones in order to subtract 24. Richie needs 76 cents. I also showed the vertical form using subtraction to solve as well. Objective. I can solve word problems involving different ways to make change from $1. First example for our concept development. If you have a scrap piece of paper, please get that out at this time, or if you have a little whiteboard of your own, you can get that out too, just like mine. I'll read it following along. Shay buys a balloon for 57 cents. She hands the cashier $1. How much change will she receive? I don't know. If she hands the cashier $1 bill, how much change will she receive? We need to change $1 to cents. Who can remember how many cents is equal to $1? $1 is the same as 100 cents. How much change will she receive if it costs 57 cents? All right, the first thing I'm going to do is make a number sentence for how I'm going to solve this. So Shay buys a balloon for 57 cents. 57 plus equals 100 cents. Or I could subtract and say 100 minus 57 equals blank. All right, the cashier is going to take away the 57 cents from 100 or $1 bill, and Shay is getting back what is left. You could use the arrow way to solve this like we've been practicing. So 57 arrow plus what gets me to a benchmark number. 7 ones plus gets me to the next 10. 57, 58, 59, 60 plus 3 equals 60. 60 plus what? I need to get up to 100. 60, 70, 80, 90, 100. 4 more 10s plus 40 equals 100. I'm going to look at those parts above the arrows. 3 and 40, that makes 43. So I think it's 47 cents that Shay will get back, or I can check this with subtraction. I'll do the vertical way, 100 minus 57. Notice that I already crossed off the 100, and I know that I need to decompose to make tens and ones, so I can take away 57. When I decompose 100, it'll make 9 tens and 10 ones. So now I have 9 tens minus 5, and then 10 ones minus 7. 10 minus 7 equals 3. 9 minus 5 equals 4. So I have 43 cents left. Those are 2 different ways that you could solve this problem. Shay will receive 43 cents. You can pause it on this slide here to add something to your work if you would like. Moving on to our second example. Jamie buys a baseball card. He gives the cashier $1. Now remember, $1 is the same as 100 cents. Jamie gets 2 dimes, 1 quarter, and 1 penny in change. How much did Jamie's baseball card cost? This one is trickier. The problem tells us the types of coins that the cashier gives Jamie. We need to figure out how much did Jamie's baseball card cost. He gives the cashier $1. Here are the coins that Jamie got back in change. Let's figure out how much money Jamie got back looking at these coins. All right, I know that a dime is worth 10 cents. 10 and 10 makes 20. How much is a quarter worth? A quarter is worth 25 cents. And a penny? 1 cent. So we're figuring out 20 plus 25 plus 1 equals 46 cents. I know 2 tens plus 2 tens equals 4 tens. 0 plus 5 ones equals 5. 45 plus 1 equals 46. So I know if he got 46 cents left. How much was the baseball card? Writing down a number sentence for this. 100 minus how much the baseball card costs, minus equals 46 cents. Here's my number sentence for this problem. If I know this part, I can make a new number sentence, 100 minus 46. Think of a strategy you want to use to solve this problem. Remember that we've been practicing the arrow way to count up, or I could do the vertical form to subtract. 46 arrow plus 4 equals 50. 50 plus what is going to get me up to 100? 50 and 50 make 100. So plus 50 equals 100. The parts above the arrows let me know what my answer is, my missing part. Again, you could do 100 minus 46 in vertical form. Can we take away 46 from 0 tens and 0 ones? No way. We have to unbundle 100 and make it 9 tens, 10 ones. Can you say that with me? 100 is the same as 9 tens, 10 ones. All right, here's what we have for how much did Jamie's baseball card cost. His baseball card cost 54 cents. Pause the slide here to check over your work. And our last example together. Penelope wants to buy a toy whistle that costs $1. She has 15 pennies, 2 nickels, 2 dimes, and 1 quarter. How much more money does Penelope need to buy the whistle? We need to figure out how much money Penelope has saved first and how much that equals. All right, so I drew a picture of my quarter, 2 dimes, 2 nickels, and 15 pennies. It's easier to count them from biggest to smallest. Let's see if you can count with me to find out how much this equals. Ready, set, go. 25, 35, 45, switch to 5s, 50, 55, switch to 1s, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. Penelope has 70 cents so far. How much more money does Penelope need to buy the whistle? If Penelope has 70 cents so far, 70 plus equals 100 cents. Remember, 100 is the same as $1. I use the arrow way. 70 plus 30 equals 100. Penelope needs 30 cents. Remember that you can always go back to the previous slide and practice counting those coins with me again if you had some trouble with that one. And that is it for our practice problems and our concept development. Problem set time. You should be turning to page 54 in your packet. Solve using the arrow way, a number bond, or a tape diagram. Now, I only use the arrow way strategy. I did not use the number bond or tape diagram models. You don't have to worry about that right now. Please just focus on using the arrow way. And if that strategy is too challenging for you, remember that you can always use a different strategy if needed. I'll read the problems for you. Be sure to pause the video at the bottom here to solve the problem on your own. And then you can always press play again when you need to hear me reading the next problem. Or feel free to just pause it right now and work independently on pages 54 and 55. Problem 1. Jeremy had 80 cents. How much more money does he need to have $1? Problem 2. Abby bought a banana for 35 cents. She gave the cashier $1. How much change did she receive? Joseph spent 75 cents of his dollar at the arcade. How much money does he have left? Page 55. The notepad Elise wants cost $1. She has 4 dimes and 3 nickels. How much more money does she need to buy the notepad? Problem 5. Dane saved 26 cents on Friday and 35 cents on Monday. How much more money will he need to save to have saved $1? That one was a little wordy. Let me read that one more time. Dane saved 26 cents on Friday and 35 cents on Monday. How much more money will he need to save to have $1? Problem 6. Daniel had exactly $1 in change. He lost 6 dimes and 3 pennies. What coins might he have left? All right, I'm going to go over the answers on your problem set. Please pause the video right now if you have not completed these problems yet on your own first. Be sure to not copy, please. Problem 1, correct answer was 20 cents. Problem 2, 65 cents. Problem 3, 25 cents. Pause the video here if you need to look at these problems for a little bit longer. Add something to your work to make it better if you made a mistake. Problem 4, Elise needs 45 cents more. Problem 5, Dane needs to save 39 cents more to have $1. Problem 6, Daniel might have 1 quarter, 1 dime, and 2 pennies left. So he had 37 cents left. You could draw a picture of any coin combination that represents 37 cents. So another way you could have drawn it was 3 dimes, 7 pennies. Or you could have done 3 dimes, 1 nickel, and 2 pennies. There's definitely more than one way you could answer problem 6. All right, I have some debrief questions for you. If you are working with somebody right now while watching this video, feel free to turn and talk with them and share your thinking. What is another way we can think of $1? Turn and talk. Another way to think of $1 is by changing it to 100 cents because they are the same value. So 100 pennies equals $1, 4 quarters equals $1. There's lots of different coin combinations that make $1 and 100 cents. 2, we're going to turn and talk about why we can take 35 cents away from $1. Why are we able to take 35 cents away from $1? Remember, $1 is the same as 100 cents. So we can change this to 100 minus 35 cents. And then we would need to unbundle our units to be able to subtract 35 across the zeros, or you can count up from 35 to 100. So here's an example that I drew. 5 minus 10 equals 5. 9 minus 3 equals 6. So we can still subtract 35 from 100. We just need to unbundle, or we can count down on our fingers. All right, scholars, if you are still with me, thanks for sticking with me. You have an opportunity for Grow Our Team points. Your homework page is on page 56. Please work on these 3 problems. You can solve using the arrow way. Remember, you do not need to worry about doing the number bond or tape diagram way. If you show your work and it looks pretty accurate, you will get Grow Our Team points for completing this page. Just please send a picture to your advisor, or you can always text a picture of it to me. Thanks. Have a great rest of your day.